Hello there, my dear students. Welcome to Science Made Simple by Ms. Flons. For today's standard, 6P3A.1, I can analyze and interpret data to describe the properties and compare sources of different forms of energy, including mechanical, electrical, chemical, radiant, and thermal. For a cross-cutting concept, energy and matter. Let us review what we have discussed in the last video. We said energy is the ability to do work. Energy exists in many forms. Energy can be moved from one object to another. Energy can be changed from one form to another. And the law of conservation of energy, energy cannot be created nor destroyed. What is always present but never visible? That is energy. Although energy isn't visible, you can detect evidence of energy. So here are the forms of energy that we have studied already. We have mechanical, that is the energy in motion. Chemical, that is stored energy. And this example here, the fuel that you fill in the car has chemical energy or stored energy. And that will be used so this car will move, so that chemical energy now has changed to mechanical energy. Electrical energy. So when you have this socket, this plug into the socket, then electricity from here will flow through the wires, that is electrical energy, and makes this light to lit up. Then there's light energy in here, or the bulb has light energy now. And then later on, you will notice once you touch this bulb, then you feel that it is hot, then there's now the thermal energy. So, and these are other forms of energy like heat and thermal, the nuclear, and the light and radiant energy that is coming from the sun as the ultimate source of light. So this morning, even though I have mentioned already some energy transformations, but our concern is all about energy transformations. So energy comes in many forms. You have the thermal, radiant, sound, chemical, electrical, and mechanical. So when you say energy transformations, this is when energy is used to move or to make things move. It is transformed from one form to another. So most energy transformations can be traced back to the sun. And the original source of energy for life on Earth is the ultimate source of energy. So here's a simple energy transformation. Sunlight, which has radiant energy, shines on the person's face, and that changes to thermal energy. Why this happens? Because your skin absorbs the energy, the molecules move faster, which produces heat. So some energy transformations take place in complex chains. For example, this toaster in here. When you plug in this toaster, electrical energy will flow to this toaster, and then you can see there that light will appear at the inside here, and then from that light, you can see the heat is being released. So that's the thermal energy now that can toast the bread in the toaster. Another energy transformation is the old-style steam locomotive. In this old steam engine, steam is used to move the pistons, which make the wheels turn. So, the radiant energy coming from the sun converted or transformed to chemical energy that is stored now, and then when that stored energy is used, heat is released, thereby thermal energy is formed, And this thermal energy now enables this old-style steam locomotive to move, and thereby that is mechanical energy. So from the word itself, steam, that means it needs heat to move. And where does that heat come from? So you see here radiant. So when you hear about the word radiant, please remember that it is an energy coming from the sun. So this radiant energy will be stored first. Chemical energy is a stored energy. And once this stored energy is being used, heat is released. Thereby, there's thermal energy. And the thermal energy now is the reason why this steam locomotive can move. And that when it moves now, that energy now turns to mechanical energy. So this is what I was explaining earlier. Old-style steam locomotive. Radiant energy from the sun is absorbed by the plants. Plants produce chemical energy through photosynthesis. When the plant die and become fossil fuels, chemical energy. In the locomotive, the chemical energy is burned. That is thermal energy. The steam created from the thermal energy turns mechanical energy. The wheels to make the locomotive move. So the steam created from the thermal energy turns the wheels to make the locomotive move. So you have energy, mechanical energy here because there's movement. Another example is the battery-powered alarm clock. From the word battery-powered, battery has stored energy. So in this battery-powered alarm clock, the hands move and an alarm rings when it's time to wake up. So since battery, it has chemical energy, and that chemical energy now is being transformed to electrical energy so that the hands can move. So once the hands can move now, there's a movement, so there's mechanical energy, and when it's time for you to wake up, the alarm rings. So that is now releasing sound energy. Solar-powered car. Most cars run by using a battery for electrical energy and gasoline for chemical energy. So the battery has a stored energy of chemical energy. Once it's used, it is being transformed to electrical energy so that it can move now, then it will have mechanical energy. When you use gasoline, the gasoline has also chemical energy. Once you use that, it will be transformed to electrical energy, and that electrical energy now will enable your car to move. Then the movement of that car, you have now mechanical energy. But in this type, the name itself, solar powered. So think about what is the energy coming from the sun. So that is radiant energy. Radiant energy is being transformed to electrical energy that makes your car move. Since it's moving now, then that car has mechanical energy. This is very familiar, our solar panels. So this is an example of an energy transformation using solar energy, which is pictured above here. First, the sunlight hits the solar panel, which you can see on top of the houses. You can see that around in your place. Transforms radiant into electrical energy. Next, the energy goes to a battery if that solar panel has a battery in there. So it is stored now as chemical energy. So when needed, the electricity goes through your house in wires. So that is electrical energy again. And lets you turn on the light. And that's now light energy. So when you turn on light, electrical energy is being converted back to radiant energy or light energy. So this is an example of a solar energy transformation. That means in this process, the sun, which is the ultimate source of energy, has radiant energy that is being trapped in the solar panel. that is the solar energy converted to electrical, stored in the battery as a chemical energy, and then when you use that chemical energy, it will be converted back to electrical energy that enable your bulb to light up, and there releases now your light energy. So when you touch this bulb later also you feel it's hot, then thermal energy is also present. Flashlight is so familiar. So the flashlight, for example, has battery inside. That battery has stored energy, and that stored energy is what you call chemical energy. And that there is an electrons in there that flow, creating your electrical energy. So the electrons in there, when they flow in a circuit, makes your light, the light of the bulb in your flashlight, lit up, and that's now light energy. And later on, if you use this flashlight for a longer time, then you will notice that the flashlight will become hot, and that is now heat energy. Okay, so those are examples of how these different forms of energy is being transformed from one form to another, depending on which way or which form you need. So let's practice together. So this is a we do in our class. So this is energy transformations. Directions: use the sequence diagrams below to explain the forms of energy that occur in order from beginning to the end. So let me do number 1, and I wanted you to do 2, 3, 4, 5 as a practice. For number 1, there's a car. It was discussed earlier that the car, when I fill in fuel to this car, the gas there has chemical energy, and then it will be stored in there. And then later on, this car, once I start the engine of this car, that chemical energy will be converted to electrical energy that can make the car move. And the movement of the car, I'll have now mechanical energy. If I'm gonna use the light of this car, then I'm gonna have light energy. When I'm gonna use the sound in this car, then I can have sound energy in here. So from chemical energy of the fuel that I use in this car, I have transformed that chemical energy into different other forms of energy. So I wanted you to do the rest of this as a practice. So that will be all for today. Next video to watch: potential and kinetic energy.